A few days back, I came across a post by Jeff from Southwest Airlines about CLAG, Kafka-lambda-event-generator. And I'd worked on Kafka AWS-based application in the past, so was curious about it. And I went to GitHub link and looked through it, and it articulated the pain points that the consumers are having about not being able to have access to be able to produce to the topic for their own testing. And I was on the producer side, so didn't really understand the pain point. What we recommended for them was to, why don't you create an internal topic which your team could own, and you can mimic the producer topic. And I don't think that's really, I mean, it's a solution, but it's not the best solution. But I feel that this solution has promise. So I wanted to check it out. So let's look at this. So this is, it's articulating the pain point very well. And so this is really good if this works. So we're going to test it out. So looking at installation options, so there's multiple options. I'm looking for something that is quick and easy. So what I'm going to do is I'm going to clone the repo and then run the steps and then configure and make sure that it's doing what's articulated here. So with that, let's go to step number one. So step number one here is to clone the repo locally. Now I'm on Windows machine here, so it presents its own challenges, but we'll deal through those. So I created a folder called swacleg, and we are going to clone the repo here. So let's go get the link. Where is it? Yeah, URL. So it's done. So let's go ahead and run the next step. So scrolling down, so it says npm install. Okay, so that's done. So the next step is um, to actually run the CLAG. And of course, we haven't configured anything, so I don't expect it to run. But let's just try and see the errors that it throws. Okay, so it's unable to find the config.yaml, so we need to place the config.yaml in the right location. And we also need to update the config.yaml. So it is looking for config.yaml in the root folder. So there is config.yaml. So copy config.yaml here, and then let's retry. I mean, we haven't changed config.yaml yet with the information it needs. Uh, okay, so it went past, so it's unable to read the decoded event file, and it's looking for a file called full decoded event.json. So let's just, I guess it's looking for under sample files. So let's go to sample files and rename this as full decoded event. Full decoded event.json. Okay, so now we have full decoded event.json. Let's try this. And of course, we haven't set up the connectivity to AWS, not to Confluent. So those steps still need to be performed. So error while fetching the secret. So we need to set up secret. So I think now we need to get into meat of things on configuring. And so it is error fetching schema register credentials. So we need to do some configuration related to that. All right, so let's look at the config file and then do some adjustments there. So in the config.yaml, we have few settings to do. So first we need to get the schema registry information host, and then we need to get the API key from schema registry and store on AWS in a secret, and then update the secret name here. And then we need to update the region name and then the schema ID for the schema which you are trying to pull the contract from, and this will just leave it as is. And then for the lambda, we need to give the name of the lambda function that we want to trigger, the region, and we'll leave the log file location the same as well. So let's get going. So let's get the schema registry information. So this is our Confluent environment. So let's go into environment and default, and let's go to schema registry. And schema registry, let's get our endpoint. So we have this endpoint. So let's go back and update in config.yaml. So we have this. Save. Now I already stored the API key. So this is the schema registry API key. So there's API keys here, and the API key is starting with EXY, and that's what I've stored in the secret. So let's go to that secret manager, and retrieve secret value. And so here it says username EXY and shows the password here as well. I'm going to delete this key, but I just wanted to show you to store as username and password keys and then store the values here. So you have those stored here. So and then the name of the key is secret name is collect confluent SR API key. So we'll copy that and update in config.yaml. Let's go to config.yaml. Okay. And it is in US East 1, North Virginia. So US East 1. Now we need to get the schema ID. So Control S. So let's go to Confluent and then go to our environment, default, cluster. We want to go to topics, shoes. And so it's called data contracts. So we go here and the schema ID is this. So we copy that and update into schema ID here and then save. So now all we need is lambda function, and then we might have to update the decoded, fully decoded event JSON, and so we'll get there as well. So let's first create lambda function. Only secret, so lambda, and create a brand new function from scratch, and you can say collect test. We'll use Python 3.12. Then we'll leave everything default and create the function. A function created successfully. And just for our testing purpose, what we'll do is we'll just print the event here, just to make sure that and let's deploy this. Okay, so let's update the config. So we need to update the function name, and it is in US East 1. So let's go ahead and update that. US East 1. So now we just need to, okay, let's try running this and see. We haven't changed the input file as of yet as well. All right, so let's run and see what happens. We haven't changed the input file yet. Okay, so that did not work. And it is saying, are you sure input matches the Avro schema? We need to make sure the input message matches the Avro schema. So this is our input. And right now, I think the key value pair is just this. So, okay. So let's just change topic name to shoes. This is all dummy data, so I don't think we need to change all these things here. I think all we need to change is, from what I read, you need to just make sure that the value matches the schema. So let's go ahead. So this is our schema, and we need to get the data that matches the schema. So let's go to topic and see if we can find messages, one of the message, and then we can plug it in. Now in practice, in the real world, you will have to get it from your producer team. So this is the message that you are really looking for. So you need to get the message from the producer team. So let's go ahead and update that. So key value pair here. And we just need to remove this extra curly braces from here and here. Okay, and save. I don't think it really, this bootstrap server or anything matters. I think it's just trying to match whatever is in here. Whatever is in here in the value field matches to the one, to the schema registry. So let's go back to the command prompt and see if it works. So let's go run. So what it is doing is, it is, oh, okay, so it did generate the event and it didn't invoke the Lambda. So what it is doing behind the scenes is, it is taking the input event and then generates the output JSON. And then as a step two, it invokes the Lambda using that output JSON and passes on to that Lambda that you mentioned in the config file. So let's look at the output JSON. This is the output you'll typically get from Confluent topic as a consumer. So let's open this in Notepad. So yes, so this is the output that was sent. This is all serialized and encoded, and this is what we should see in Lambda as well. So it should have triggered this Lambda. So let's go ahead and look at the logs, see if it triggered. So you can go to CloudWatch logs. Okay, so we have log stream. So let's click on this. Yes, so it did print the incoming event. And this is exactly what we were like. So there's a two-step process. One was to generate the outgoing event. Second was to trigger Lambda or invoke Lambda. So that's what it did. And so we can, both the steps we can run individually um, through subcommand. So we can do things like generate, and it will just generate the output message. And the way we can actually prove is, we can delete this from here and then rerun again. And so it would, without, so it would should generate. Okay, completed. So the output was generated. And if you look at CloudWatch logs, it did not, sorry. If you look at CloudWatch logs, it should not have triggered. So nothing new here. It was the one we saw earlier, so nothing new here. You can delete this too. And now if we just run invoke, then it is not going to. So if you look at it is not going to generate. It is just going to use the file that was generated here to invoke Lambda. So We'll keep a note of timestamp. It is 5:20 p.m. is the timestamp for this file, and it's 5:21. So let's go ahead and run invoke. Okay, invoke Lambda. So if we look at the file here, the file is still the same. So, but if you look at CloudWatch, it should have had triggered Lambda. So this is the triggering of the Lambda, and in the Lambda, we're just printing the incoming event, and then there can be further processing done. But I think this checks out. I think one of the advantages, big advantage of this is that your reliance on consumer or reliance on producer is highly diminished. What you need from producer is the information on schema registry and a sample message, and plus the API key, the way to be able to connect to schema registry, and then you are all good to go. You don't need to produce any messages. You don't have to do anything, and then you are able to start your development or even do performance tests, things like that, without involving the producers. This is a very useful tool. I like it. So yeah, thanks Southwest for building this and sharing this on GitHub. Thank you.